All right. So in this video, I'll be going through pages 8 and 9 in the notes packet. You should have just done the notes on page 7 and tried these on your own. So I'm going to go through them so you can check your answers again what I do, or if you're stuck on any of them, you can see one way to approach it. All right, so here we're just graphing. So for this one, I'm going to start with my y-intercept at -2. If our slope is 7 over 2, I'm going to go right 2 and up 7. So I can put another point there. And once you have 2 points, the line just connects them. You can draw that a little better. It's marginally better, but we'll take it. In this one, we have a y-intercept of 3, slope of -6. So we're again going to go over 1 and down 6. So you should get something that looks like this. Connect the line between them. Y equals -5. All right. So this one, we can think about it. Imagine this where y is equal to 0x minus 5. Right? That's the same thing as saying y equals -5 because 0 times x is going to be 0. So we want to do our y-intercept of 5, and now when we have a run of 1, we have a slope of 0, so we have a rise of 0. So this is just going to be a horizontal line at y equals -5. Another way you can think about it is these are all of the y values, or these are all of the points where the y value is equal to -5, right? This is kind of 1, -5, 2, -5, 3, -5, 4, -5. What they all have in common is their y value is -5, right? When we're thinking about where we are up and down, we're always at that same y value. Okay. So this one, you have a y-intercept of 1. Now we have a slope of 6/5. So if we go over 5, we try and go up 6, we're going to end up off the graph. So we can, if we want to, kind of say the point's going to be about there. But in this case, you could also just go the other way, right? If the slope is positive 6 over 5, then you can either go right 5 and up 6, or you can also go left 5 and down 6, right? Left 5 and down 6, and that's the same thing. So now we can draw our line through all of those points and call it a day. All right, now this one is in standard form. I'm going to do it by finding the intercepts. You can also do it by translating it to slope-intercept form. You will get the right answer, or you'll get the same line if you do it correctly, either way. So I'm going to start by finding my y-intercept, finding my x-intercept by setting y to 0. So 2 times 0 is equal to -10. 7x is equal to -10. So x is equal to -10 over 7. -10 over 7, comma 0. So that's going to be a point like right about there, right? It's a little bit less than -1.5, or a little bit less negative than -1.5, I guess would be the way to think about that. And then to find the y-intercept, we'll plug in 0 for x. So 7 times 0 plus 2y is equal to -10. That would be 2y is equal to -10, or y is equal to -5. So my y-intercept is 0, comma, -5, meaning that the slope of my line, or meaning that the path that my line is going to follow is going to look like that. And if you converted that to slope-intercept form, you would end up with something that looked like y is equal to -7 over 2x minus 5. And that seems pretty reasonable for what we ended up there. As you see, we kind of have a point right there, and that would be starting at -5, going up 7 and left 2. So yeah, I think that works out. Once again, I'm going to do the intercept method here. So if we're finding our x-intercept, that means x minus 2 times 0 is -6. So x is just -6. So our x-intercept is -6, 0. And then to find our y-intercept, we have 0, comma y. So that's going to be 0 minus 2y is equal to negative 6. That's going to be negative 2y is equal to negative 6. Divide by negative 2, and we get y is equal to 3. So our y-intercept is 0, 3. So it means we have one intercept there, and then the line, of course, just connects the two. Okay. Moving on to page 9, here we have some application problems. So at a sushi restaurant, nigiri costs $4.50 per serve, and sashimi is $9 per serve. Hiroko spent a total of $45 buying X serves of nigiri and Y serves of sashimi. So it says, explain why 45x plus 9y equals 45. And here I'm going to say 4.5, it's still on shape mode. So 4.5 is cost of one nigiri. So 4.5x is the cost of X nigiri. And then we use similar logic for sashimi. So 9 is cost 1 sashimi. So 9y is the cost of Y sashimi. And the sum of all of the sushi, is $45. So we have essentially this part represents the total amount of money spent on nigiri. This represents the total amount of money spent on sashimi. This is just the total amount of money spent between the two. All right, so if you bought 4 serves of nigiri, well then that means our X is equal to 4, right? Because X serves of nigiri, meaning that sorry about that. Meaning that if we use our equation, we would have 4.5 times 4 plus 9y is equal to 45. That means 18 plus 9y is equal to 45. If we subtract 18 on both sides, then we get 9y is equal to 27, which means y is equal to 3. So 3 serves of sashimi. All right. And if she bought 1 serve of sashimi, how much nigiri did she buy? Well, now we're going to let y equals 1, and once again use our equation. So 4.5x plus 9y, or 9 times 1, is equal to 4.5, or sorry, is equal to 45. Meaning 4.5x plus 9 is equal to 45. 4.5x is equal to 36. And if we divide both sides by 4.5 there, we're going to get x is equal to 8. So 8 pieces of nigiri. All right. So now we can graph this and we can use our 2 points. So for this point, we have x is equal to 4 and y is equal to 3. Right? 4 pieces of nigiri and 3 pieces of sashimi. Or y could be 1 and x could be 8. We can also add a couple more points here using our intercepts. So if she spent all of her money on sashimi, well, she could buy 5 serves of sashimi, because 9 times 5 is 45. Or if she spent all of her money on nigiri, she could buy 10 serves of nigiri, because 4.5 times 10 is 45. So those are all of the possible, right? Those are 4 possible combinations that she could buy. And all of the points between them, right? That whole line are all of the possibilities that she could buy. Okay. And so now we have this table that shows the annual temperatures for Earth recorded at 50-year intervals. So X is our year, temperature is our Y. So we create a linear model for this data by simply finding the equation of the straight line that passes through these 2 points. So this is just an application of finding the slope of the line through 2 points. So we're going to want to use our formula, right? The slope is equal to y2 minus y1 over x2 minus x1. That means it's going to be 9.45 minus 8.73 over 1958. I don't know why I put a decimal there. 1958 minus 1708. So we go over here. So it's 9.45 minus 8.73 divided by 1958 minus 1708. Then we hit enter. See the gradient is 0.00288. 0.00288. And this is in degrees per year. That's the unit there, right? If over the course of, so it's 250 years, the temperature increased from 8.73 up to 9.45, well, it increased by 0.00288 degrees per year. Okay, so now we want to find the equation of the line in y equals mx plus c. So c is just another way to write our y-intercept here. But we know we have our slope, right? Our gradient is this. So y is equal to 0.00288 x plus c. And now we just need to figure out what is our y-intercept, right? We just found the gradient. Now we need to find the y-intercept. And to do that, we can use either of our points here. So I'm going to choose this one, where x is 1708 and y is 8.73. I'm going to say 8.73 is equal to 0.00288x plus c. And sorry, instead of x there, I'm going to use the x value that we know, 1708 plus c. And therefore, if I rearrange this, I'm going to get that c is equal to 8.73 minus that sum, or that product over there, right? 0.00288 times 1708. So first I'm going to take this and multiply it by 1708. And then I'm going to take our 8.73, our y value, and subtract that. And we will get 3.81. So c is equal to 3.81, meaning that our total, our entire equation here is 0.00288x plus 3.81. And at this point, I'll ask you, since this is an applications course, I'll ask you to take a step back here and to think about what would this model imply? Like, what does this y-intercept mean in the context of this model, and do we think that is accurate? Just take a moment, try and figure out, if you were to interpret what does this point, or what does this 3.81 mean in the context of the problem, what would you say? For me, I would say, well, if this is the temperature in year 1708, and this is the temperature in year 1958, well, then the y-intercept, right, these are our x values, those are our y values, our y-intercept, so this must be the temperature in the year 0. So in the year 0 CE, according to our model, the temperature should be 3.81. And the question is that reasonable? Probably not, because if you know anything about the world, you probably know that the recent rise in global temperatures is because of the increase in carbon dioxide from the Industrial Revolution kind of onwards. Right, it's man-made changes to the atmosphere. So if we think about our model starts in around the start of the Industrial Revolution, it's probably a poor predictor of what came before 1708. So we would just be hesitant to extrapolate our model beyond the time frame for which we have data for.